So we're going to take a headfirst dive into Azure Synapse SQL Serverless Pools, kind of a new feature in Azure Synapse Analytics. So let's see. So a little bit about me. We already did an introduction, so I think I'll just skip over that stuff. A little background around Azure Synapse Analytics just in general, in case you're not familiar with it. So what Microsoft is trying to do here is they realize that when you're building a data platform solution in Azure, you've got to stitch together a lot of different services. So you might be using Azure SQL database as a backend database. You might be using Azure Data Factory or maybe Databricks to do some data engineering. You might be using Power BI to do presentation and visualization, and a lot of other services like Key Vault, so on and so forth. But the key concept here is that Synapse Analytics is giving you kind of a unified experience, so a single environment in which you can author data pipelines, you can do data visualization using Power BI workspaces, and then you can connect to data sources, and those can be in Azure storage accounts or in dedicated or serverless pools. So serverless pools is kind of a new thing. So prior to the Azure Synapse Analytics, we had what was called SQL DW, which was a massively parallel processing data warehouse system. Serverless pools allows you the ability to leverage that MPP engine and use your kind of familiar T-SQL to query data that's sitting inside of a data lake. Okay, that's pretty much what it does. So it allows us to take this Azure Data Lake storage and run SQL queries on top of it. And it's a consumption-based model, so you only pay for when you're running queries. So there's no persistent database storage. So with that being said, let's keep going and take a look and take a look at, we'll do an overview of the architecture, look at cost management, resource consumption, some use cases, and then we'll get into actually querying some data sets. So serverless pools is a MPP engine. You have a control node that takes queries coming in, and then compute nodes that you don't have any control of. So you're not provisioning like in a dedicated pool or even in a SQL data warehouse. You provision something, you say, I'm going to use this much compute, and you're paid for that. With serverless pools, it's going to take a look at what your incoming query is, and it's going to automatically spin up the right amount of compute nodes to distribute the work across your storage account. And so all that work happens seamlessly behind the scenes for you. So all you do is write queries. You can define tables, views, other structures, but nothing's persistent. And so you might scratch your head a little bit and say, well, how can I define tables when none of my objects are persistent? And the answer is that they're external tables. They're tables that are put on top of files that are inside of your Azure storage. So we'll look at those in a little bit as well. And it's an interactive query service, so you can issue your query and you run it. You can connect to it with all of your tools, so Azure Data Studio, SSMS, Power BI can all connect to that Synapse Serverless SQL Pool endpoint, just like a normal SQL server. So you don't have to use new tools, you can use the ones that you're already familiar with. There is also a web-based authoring experience, which we'll look into in a few minutes as well. You can query files directly in Azure Storage using T-SQL. You can build logical data warehouses on top of it, and you can use it to store and aggregate data that is in flat files or different file types. We'll talk about the file types that you can query from. And the nice thing about it is there's no infrastructure upfront cost, no resource reservation. You pay only for the query execution, and it's very cheap. It's you're billed for the amount of storage you process, and I think it's something like $5 or around there per terabyte. So it's pretty inexpensive, it's fast, it's scalable. There's a lot of functionality there. It's still being built out, so there's still some gaps in various areas, but it's a pretty solid platform, and it unlocks a lot of really cool scenarios. So if you guys have heard a lot about the data lakehouse architecture, this is kind of the Synapse way of building one of those, is to create this logical data warehouse. It's kind of a replacement for the lakehouse pattern. You can integrate with other Azure services, so anything any kind of access you need to this, you can hook it up. It supports standard SQL. And the other thing that's kind of cool here is you can create stuff in Apache Spark pools. So Apache Spark Pool is similar to like a Databricks. It's a Spark cluster. It has its own storage. It can use data lake storage, but it has built-in internal storage as well. But you can create table definitions, and because that meta store is shared between the two, I can create a table definition in Hive on my Spark table or my Spark pool, and it'll automatically pick that up in Synapse Serverless. So that's kind of a cool thing. And under the hood, they're both talking to the same storage. So that's kind of a useful feature. And this is what we're talking about. So you can see here, I've got a Synapse notebook here, and it's using this magic command. So anytime in a notebook you see a %%, that's called a magic command. This is %SQL, which says I want to do a SQL cell. I'm going to create a table called data 1017. It's going to use Parquet as its underlying storage, and the location is going to be Azure Data Lake or Azure Blob File System. You specify the container name, so each storage account has a container name, and then it has a storage URL, and then the folder within it. So this basically says, grab anything underneath this data folder and expose it as a table using Parquet. And you're going to say, well, where's my schema definition? How do I know? And the answer is, for Parquet, it can automatically infer the data types because Parquet is a binary file format that also has some metadata associated with it. And then you can see down in here, I can run a select top this is in serverless now, and I can run a select top from that table, right, and get data back from it. So that's the shared meta store. It's pretty neat. The resource consumption model, so like I said, it's about $5 per terabyte. Serverless pools are always available, so you don't need to pause or resume or scale. All that stuff happens for you behind the scenes. So as soon as I connect to my workspace, I can start running queries against my file systems. There's no DWUs or service tiers, and it scales elastically to my needs. So another thing to look at is cost control, right? Because since you pay per query, obviously, if you had thousands of queries running a day, you might want to put some limits on that. And so I'll actually walk through this in a demo, but the key concept I'm trying to show here is that you can put limits at a daily level or at a weekly level or at a monthly level, and you can combine these to kind of get the result that you want and limit the amount of data that goes through. And then once you hit that limit, it won't process any queries. The other interesting thing about this is, while the amount of data you spend for the Synapse is going to be based on the amount of data that you read and the amount of data that you write, okay? Other things that you might be using, such as the Azure storage account, will be billed separately, or if you're connecting to a Spark pool or a dedicated pool to get some data, or if you're using Synapse pipelines or Azure Data Factory or Databricks, that stuff is all billed separately. But just to run queries from storage, that is what's included in this 5 terabyte. Okay. And take a look at some different scenarios. Really, there's 3 primary ones that I think are useful. So one is, I think it's really handy to do quick data exploration and data validation. So if I get a Parquet file or a JSON file or a CSV file from a third-party source or from another team in my department, I can load that into a storage account, spin up serverless really painlessly, and just run queries at it and do some profiling, data quality assessments, making sure that the file is formatted correctly, it has all the columns we need. So that's one scenario. Second scenario that can be really useful is for data transformation, and I'll spend a bunch of time later in the session talking about the different patterns there. But the key idea is that I might have data coming from CSV or Parquet or JSON, and I want to either aggregate that data, or I want to transform it into another format, or I want to just move the data between different storage containers and accounts. So that's kind of a second use case. And then the third use case would be a logical data warehouse. So this is a case where I'm kind of trying to do a lakehouse. I've got, let's say I have some pipelines that export all my OLTP databases, and then we transform them into kind of dimensional schemas and store those inside my storage account. I can put a logical data warehouse of views and tables on top of that and kind of transform it and have facts and dimensions. And then I can put something like Power BI in front of it, right? So that could be useful. I could also do reporting services, Excel, anything that connects to a SQL endpoint, I can connect to serverless. Just some roles. This is kind of obvious, right? But data engineers, data scientists, analysts, BI professional, anybody can use this as a pretty simple tool to use. We'll take a quick walk through it here in a second, I think. So let's look at some of the file types and different functions that are available to us in serverless. So right now, there's 3 supported formats: text files, JSON files, and Parquet files. There's no ability to perform any DDL because the data isn't stored inside of a SQL engine of any type. It's all stored in the file system. Now I can read in a file and do some manipulation and write that result back out. So I can update, modify, and transform the data, but I can't do DDL from SQL. So what I can't do is do updates, inserts, deletes. But I can do, if you're familiar with dedicated pools, they have a concept called a CTAS or CETAS, create a table as select or create external table as select, and I can do those. Okay. There's no internal storage support, and there's no support for ORC or Avro files, which probably aren't super relevant, but more relevant is Data Lake or CDM, Common Data Model. We don't have support for that right now. There are open feature requests, and there is kind of a hack. I'm not going to cover it, but if you have Delta Lake, there is a way to read the metadata and actually look at a snapshot of a Delta Lake file, because under the hood, Delta Lake is just a series of Parquet files. So there's a couple different methods that are unsupported of accessing the Delta Lake, but I'm not going to cover that. And I'm hopeful that in the future, hopefully in the near future, that both Delta Lake and CDM will be supported. I think those are the two big gaps, I would say, as far as file formats that aren't supported. Because pretty much any tool, ETL tool, is going to be able to dump data out to a CSV file, and then you could transform that to Parquet if you wanted to. You wouldn't have to do it. It might be more performant. And then JSON, you're going to be able to get that from a lot of different web APIs. So they do cover the bulk of this use cases, I think, for most folks. So CSV, it's human readable. There's no standard encoding. There's many custom formats. There was an attempt to define it in RFC 4180. Basically, in order to query it, I leverage this open row set construct. And so you can see here I'm doing a select top 10 star from open row set, and then I'm saying bulk, and then I'm passing a path to the file. And notice here I'm using a data source, so we'll talk about that a little bit more in depth. But you can think of as a data source as just an abstraction that points to a URL and potentially provides the credentials to access that resource, all wrapped up in one. If I didn't have a data source defined, and let's say this was just I had a full URL, I could point the full URL to this and still pull data from it. I would need to pass in credentials if it didn't allow anonymous access. Okay, I tell it the format, so in this case it's CSV. Parser 2.0 is kind of the more efficient version. I'm not sure if it's the default or not, I don't remember. And then here I'm doing first row is equal to 2. That's because this CSV file has a header and I want to skip that. And then I'm just naming it as rows, and then it's just going to select from that. Okay. There's support for custom row and field terminators, so there's a little bit of flexibility there, as well as escape characters, so we'll look at that. So what's interesting is if you have a Windows file, you typically see a CRLF as your row terminator. So that can be specified in here by doing the row terminator as a /n and the field terminator as a comma, right? So that will support that. You'll notice this query is a little bit more advanced, and it's only going to define the columns that I need. Okay, so in this case, I only need country code, country name, year, and population. I'm defining data types to those because the CSV file doesn't have any metadata, so I can pretty much tell it whatever I want. As long as this field is implicitly castable into a big int, it'll work. If I put something like a date here, it might try to do something, or it might just completely fail, right? The other interesting thing to note about this, and I'm not the right person to talk about this because as an American, we know nothing about collations in general. But what's interesting is SQL Server introduced these new collations that basically support Latin data types. And so I need to define a collation, or if I want to load this data efficiently and have it sort correctly, I want to define a collation into it. And so with SQL Server 2016 and with serverless, there's now a new set of collations that allow me to load what used to be nvarchar characters into varchar fields. And so in some cases it can make it, especially if you're just using Latin alphabets, it can make the storage use more efficient. It can improve performance. So we'll talk a little bit more about that later. And then again, we can look at if we just have a Unix style, then we can give it this control character here for the row terminator that just says line feed. Field terminator is the same. We've got the same kind of format and parser version as before, same collation. And then we can also apply a predicate directly on the file so that we're only going to get, for example, Luxembourg in the year 2017 back. Even though the screenshot shows Slovenia, that's what you get when you steal images off the internet. So it also handles tab separated. Okay, so it's still going to be CSV file, but you're going to specify the tab as a field terminator. and the row terminator, first row equals 2 to skip that header. And we're doing Linux encoding there. Okay. So summary of some of the different terminators. I thought this was kind of interesting. It's kind of an older throwback. So you notice that special character we use for the Linux encoding is the hex value for the line feed character. It's the decimal 10. This will come up again in the future, but there's also abilities to use other characters. So when you're working with JSON, for example, if you have single line JSON or multi-line JSON, you need to use certain values of these to make it all work for you. And then of course 13 is our carriage return. So summary about some terminators. We also might need a situation where I need to quote certain string values because, for example, there might be a comma inside there, and so I can define the field code. So notice I'm using single quotes and then a double quote inside that, but that could be any value that the generating file puts out. So some places might use single quotes, for example. They might have pipes, they might have other types of delimiters, so you have complete control over those delimiters is kind of the point of this. And then if I need to escape it inline, here I can define the escape character as slash, and then you can see in Slovenia, for whatever reason, there's a comma in there, and I don't want that to split the string into two different columns, so I can escape it by putting a slash in there. And as long as I tell the open row set command that I have an escape character present, it'll support that. So you might run into some strange formats. So if you can control this a little bit, probably what I would recommend is doing double quotes around everything and doing an actual CSV file. But if that's not an option, at least you might have the ability to control putting an escape character in there. What's really cool about this as well is I don't need to actually define the schema. So I can just do a select top 10 star and it'll pull the data. Here you can see I'm doing a Parquet file, and you can see I'm able to use wildcards and format as Parquet. And then it's just going to go in here and pull the data back and make an assumption about what it is. And we'll look at some SP described first results at some other ways to see what the metadata is for data exploration purposes. But that's an option. So when you're dealing with files where the schema is unknown, it's a good way to kind of handle that. We talked about this already a little bit, but there is, like I said, with CSV files, there's a way to specify the schema and what the data types are that we need. The other thing is it's got to be an ordinal position. So this would assume that country code is our first column. If country code was our third column, then we'd have to specify additional metadata to make this all work out. And I've got a demo that'll look at that. The idea here is that if you have, like, let's say you have 100 columns in your CSV file, you only need maybe 10 of them to do an aggregation. If you just bring these 10 columns or these 5 columns into your query, it's going to be more efficient to improve performance. And the same thing with some of the predicate pushdown and things like that. So if you specify in your where clause to eliminate certain files or folders, depending on how that's set up, that can improve performance as well.
Jason, can I just nip in quickly?
Sure.
This question is probably better answered now. So question from Ricardo. Can you explain again the scenario where you extract data from OLTP and load it into OLAP system like Power BI or AAS?
Yeah, sure.
Trying to understand exactly where we can put this technology in ETL.
Yeah, it's a good idea. Let me I'll tell you what. No, let's just go back. So this would kind of show it a little bit. So the idea that what's missing from this picture is, okay, here I've got my OLTP database, right? So I have a OLTP database. Let's just say it's a JD Edwards database. So JD Edwards is an ERP system. There's lots of different ways to get data out of there, but the assumption is that we have some mechanism, maybe using SSIS or Azure Data Factory or Synapse pipelines that can pull the data out of the JD Edwards tables and dump them out to text files. So let's say, for the sake of argument, that we're going to dump that data out into CSV files every night. We're going to store those in our Data Lake storage account, and we'll take a look at that. But the idea is we might have a folder for each entity in JDE. So we have a customer entity, we have a sales order entity, and we might have a product entity, right? So we write the queries to dump that data out to flat files, and then we can put it into into Synapse, and if I needed to do some like column renaming or maybe some aggregation or some transformation, I can leverage Synapse Serverless as like the lightweight transformation. And since we haven't looked at queries that do that yet, it's kind of hard to kind of talk about it, but later in the presentation, I'll show you guys exactly how that works. But the idea then is that Power BI can pull directly from Synapse Serverless. Now, that's not to say that if you had a very simple data model, let's say you're doing website clicks and you only have 15 columns that you care about, you could certainly write code to, for example, pull the data. Let's say you're using Google click tracking, dump that data out to a JSON file and then put Power BI directly on top of the JSON file and just load it into a Power BI data set. So you can still use the Power BI data set, but in this case, you wouldn't have to. You could do direct query directly to Synapse Serverless using SQL and then pulling the data in kind of dynamically. So the use case for that, which could get expensive depending on how many concurrent users you have and how much data you're talking about, but when you need really low latency data and the data is being written out, so maybe you're using like a replication tool like Click, or formerly Attunity Replicate, they can generate change files in near real time directly to your Azure storage, and then you could then use Power BI in direct query mode to get direct access to that data as it kind of changes. Or you could do some transformation on it, add a little bit additional latency, and refresh your data set every 2 hours or every 3 hours, depending on what your use case is. So hopefully that helps a little bit. But we'll see some more examples of theirs when we start looking at transformations in logical data warehouse. Hopefully it all kind of click and come together. But if it doesn't, ask at the end of the session and we can talk through it a little bit more. So what we looked at earlier is we were actually using this external data source. So we specified just kind of the rightmost piece of the file path, and we declared a data source. So in this case, I have to preset that up. And so what I'm doing is I'm creating an external data source. I'm saying the location is this URL. So it's SQL on-demand storage.blob.core.windows.net. And then I'm doing a credential tag. So that's, and we'll look at how the credential works. If it's anonymous access, though, then we can just specify the URL and we don't need to provide the credential, and then that'll work. So in this case, Azure actually provides this yellow taxi data set for us, and it's a read-only anonymous storage account. So I can actually mount that storage account from within my serverless. Even though that serverless workspace or that Azure Synapse workspace is in my Azure account, there's nothing to prevent me assuming I have access to using other storage accounts that could be in my subscription, could be in Mark's subscription, could be in Azure subscription. As long as I have a credential or they allow anonymous access, I can pull that data into my Synapse workspace. And so this is just showing the different protocols. So I would definitely recommend that you're using Azure Data Lake Gen 2. And this is just showing the format typically of the URL. So you note that for Data Lake Gen 2, we're going to probably want to use HTTPS. We're going to have a storage account name.dfs.core.windows.net, and then the container, and then the subfolder. And we can take a look at what a storage account kind of looks like in a little bit. But you can also access these other data types as well. So there's other ways to other storage accounts if you have legacy access. It doesn't support, for example, like S3 or anything like that. So it does have to be an Azure storage account, but that's kind of an interesting maybe use case for a feature request in the future. The other thing is, with big data systems like Hive or Spark, they typically have this partitioning scheme. And so what you'll see a lot is in the URL here, we have year equals star, month equals, and then here we're using 1. So we're actually hard coding to January, and then star.parquet. And so what that is if the system, the underlying compute system supports it, it can actually expose year as an attribute, even if it doesn't exist, just by knowing that in this case, they'll say, okay, for year, the folder name is 2001, or it could be 2017. I'm saying, give me any of them. And then I can actually promote that as a column in the data set. Now, the underlying data source has to support that. Synapse has some functions for file name and file path that support that pattern, but they also support this wildcard. So in this case, what I'm saying is only give me the January files and aggregate them up. So that's wildcards. I can query partition data. So in here, what I'm doing is I'm saying, I'm using a predicate to say, hey, the file path, which is a function for the first predicate, has to be equal to 2017. So what it's going to do is it's going to go look for the first wildcard in here and say, okay, I'm only going to look for year 2017. And then for months, I'm only going to look for the fourth quarter. So October, November, December, and that's going to be for the second wildcard. Okay, so that file path function can access it. And then notice here, it's actually going to use the file path function with a ordinal value to actually provide the actual value. So here we're getting 2017. That's always the same because we only have one value, but here it changes per row. We've got 10, 11, and 12, and then we've got our row count. So using count big, and then we're grouping by those those three fields to make sure I get the right values in there, and then I can order it. Okay, so that's pretty helpful, helps with performance. That we're showing Parquet here, but that works with CSV files or JSON files as well. So that's a new function that's available to us. That's the file path function. So JSON is another file format that's supported. It's getting a lot of popularity. You'll notice a couple, if you're not familiar with it, basically you're gonna have squiggly braces to hold objects. You'll have square brackets like this to hold arrays. So in this case, we have a children array that has Suri, Isabella, Jane, and Connor as children. And then you'll notice there's an actors array that has an actor for Tom Cruise and an actor for Robert Downey Jr. So there's gonna be two rows. Each row is gonna have children that has an array, so we can explode that array out. A couple things to note about JSON: there's no support by definition for comments, so I can't put inline comments in here. Null values usually won't even be present. So if I have a JSON field like let's say parent, if there was no value for parent in here, I could reference it from JSON and I wouldn't get an error. It would just say null. So if something doesn't exist, it's just usually omitted. In some cases, like here, you have wife equals :null. That could be another way to do it, but a lot of APIs and stuff won't omit this type of JSON. Usually that's an option you have to specify to say, if I have missing values, omit them as null, because it's overhead because it has to write out all that text data for no values. And then there's two types of formats. So there's standard and line delimited. So in this case, here's kind of our array based. And so we have a line for each one. We have a single array and then multiple lines in here. And so to access this, we've got to give it a special hex code. So that's the vertical tab. And as long as that's present in there, it'll actually allow us to access that. If I have multi-line where I have single lines in each, so notice the difference. Here we have either a set of objects or a set of, or an array that has it all in here. And so once I load this up, then I can further shred it. Here I just have full JSON records as a single line, right? And so here I give it this value. I can parse these and it'll treat each one of these as an object. So this will give me 3 rows and this will give me 3 rows, just in different ways to access it. And we'll go through a demo of that to make it a little bit more clear. So in SQL Server, I believe it was 2016, we got native JSON support. So all the functions, or most of the functions, such as JSON value, JSON query, and OpenJSON are available to us. So here you can see what we're doing is we're putting in that 0x0b for the Terminator. We're telling it it's a CSV even though we know it's a JSON file. So there's not a format JSON, it's just CSV. And what we're doing is we're loading the doc into a varchar max, and then we're setting the title, and we're saying go into the doc and give me from the root, give me the metadata.title element and metadata.authors and give me the first value. And then we can do other forms of complex processing as well. And so there's the OpenJSON basically allows us to support nested types and arrays. So if I need to explode that JSON out and have 1 row per each child, I could do that, and I'll show an example of that in a second. So this is just kind of taking a look at kind of more of a simpler value. So in this case, if I'm looking at it, I could go in here and get scalar values. So because address isn't a scalar value, or tags is not a scalar value, so you can see address is actually an object because it contains other properties such as town, county, and country, and tags contains an array. Those would be returned as null values. However, info.type is a scalar value, so we have type:1, that'll return 1. Info.type, so I go to info. There's also a type property here that's at the at a sibling level to info, and so that's set to basic. And so you can see I have basic. So even though those two field names are the same, because of its place in the hierarchy, I can query down into them and resolve the correct ones. Now, if I want to resolve the address values and the tags, I have to use the JSON query. So in that case, I'm looking for objects. So it's almost the reverse of what we did. So info.type, because it's expecting an object, is going to return null for us instead of basic. But if I use JSON query to query info.tags, I can get that array. So sport and water polo. And then info.address will give me a JSON object back that has properties of town, county, and country. So hopefully that makes sense. The JSON processing looks a little weird and takes a little bit to get your head wrapped around, but once you get the hang of it, it becomes pretty easy to work with. And then OpenJSON is how I could take, and so you can see here what I'm doing is I'm going across the document, and then I'm cross-applying it, and so I'm turning columns into rows. And this one's actually pretty complicated, but it's basically going to give me some values from this record set, and then I'm doing some filtering on it as well. So we'll look at that in the demo upcoming. So that's JSON formats. Parquet formats, it's a format, if you're going to do a lot of queries kind of ad hoc against your data lake, Parquet format or potentially Delta Lake are probably the two best formats as far as from a performance standpoint. The reason is they're not text files, they're binary, so it hurts your discovery a little bit, but they support compression and predicate pushdown. So the folder pushdown that I was talking about earlier over here is a little bit different than this predicate pushdown that I'm about to talk about now. So you can think of a Parquet file as pretty much a file-based column store index. So every row is going to be stored in a row segment, and then the values are going to be compressed using RLE, so run length encoding, as well as some other techniques to get the most amount of data into the smallest amount of space. So these next slides go pretty deep. I'm just going to cover it at a really high level. So this is the metadata of the Parquet file. Basically, there's a header, and then you have different segments within it, and then you have a footer, and then you have some metadata and some other stuff that's kind of just not super useful for what we're talking about. The key concept is that you're going to have row groups and then column chunks within those row groups, and that's how the predicate push down. So it's going to look through, and that row group is going to maintain a statistic and say, here's the min and max value of this column inside this row group. And so if your predicate is outside of that value, it doesn't even have to read it. It's just going to skip it to the next row group. Okay, column store works very similar to that. So I've got two examples here. One, I'm just showing you that I can query it directly. So there's no security on this. This is an open blob account that Microsoft maintains. And so I can select from this cases.parquet file, format Parquet, and just query the data. Or I can create an external data source. So notice here I'm providing the location all the way up to the subfolder. And then from here, I just, in the bulk section of it, I say latest/ecdc_cases.parquet, and that's what I'm grabbing from up here from the open row source. So two different ways of doing it. This, if I'm going to run multiple queries about it, creating the external data source is probably best practice. It's going to help you so you don't have to have as much complexity in your bulk statement here. It makes the queries a lot easier to read and look through, assuming you know what's going on. And then this is what I'm saying. So these Utf-8 collations, so by default, Parquet uses Utf-8. And so what will happen is if you load it without specifying a collation on the column, you'll get a warning, which we'll look at a demo of that. I have two options. One, I can specify the column collation. So I can say Latin 1 general 100 bin 2 Utf-8, or I can set the database collation at that, and then by default, it'll all go away. So we'll take a look at that. And we already talked about wildcards. So just a summary of the different file formats that are supported. We have CSV, we have JSON, and we have Parquet. Parquet is really the one that's optimized for analytics. CSV and JSON can work for smaller data sets, but the typical pattern would be to grab the data in either CSV or JSON as it comes from the system, and then transform it into Parquet before you run your analytics queries on it. You don't have to do that, but it's kind of a pattern that happens. Now, the drawback for CSV is it doesn't support complex types, so I can't have arrays in my CSV file. I can't have nested objects, whereas JSON and Parquet does do that. The drawback for Parquet is it's binary, so it's kind of cumbersome to look inside that file and see what's there, whereas CSV and JSON, I can just open it up, right? That's not to say that I can't take a tool like Notepad++ and open the Parquet file and see the data in there, but it's going to be really hard to read. But there are some cases where you might want to do that to look at the metadata and some of the other structures. So let's take a look, and I'm going to save the demos, I think, to the end, but let's take a look at some data transformation, because this I really think is the main use case for using serverless. Is when I have full data extracts coming from a source system and I want to work out the deltas. There's some other scenarios too, but this is where it's really useful, or I just need to change the format or reproject it. So in this case, what I can do is I can take my CSV files, run a SQL query, and that could be a group by, or it could just eliminate columns I'm not interested in, dump them out to Parquet, and then run my analytical workloads on SQL. And I can run that all from Azure Data Studio or Management Studio or Power BI. I can repartition the data. I can build SQL-based ETL pipelines. So I can do a lot of different things in here, and I can do some lightweight orchestration. So the primary way to do that is to create an external table. So what I'm doing here is I'm saying, okay, I'm going to create this external table called parquet.population. I'm going to say it goes to this /parquet/parquet population folder. I'm going to tell it the data source, so that's giving me the connection and the authentication, and then I'm going to use the Parquet file format. Now, this file format is a little bit different than the file format I was using in the querying section. So the file format in the querying section is either CSV or Parquet. That's all I specify. This file format is actually something that I need to create, and we'll look at that in a second. And then what I'm doing is I'm saying, okay, create this external table as select star from CSV population. So in this case, CSV population is probably another external table that I've already created, or it could be a view. But the idea here is that once I run this statement, what it's going to do is it's going to read all the data from whatever's in CSV population, dump it out to a Parquet, one or more Parquet folders or files underneath the population folder, and then I can read that data again. I can create a view on top of it. I can do all sorts of other stuff on it. So here you can see I can get a little bit more complex with it. So I can have a location, a data source, a file format, but I can also do the group by on it, put a predicate in it, and then it'll just dump that result out to population by month, and then to this folder 2017. And now I can also select data from it as well. Now what's interesting is once I need to update this, let's say somebody's going to put more data in here, it's not going to automatically update. And so what I'm going to have to do is I'm actually have to physically remove that data from the folder and then recreate that external table to insert new data into it. And that's primarily if I was doing aggregation. If I added data underneath this folder that was in the right format, it would pick that up, right? But in this case, it wouldn't. There is a wizard that helps you go through this. I'm not going to spend a ton of time on that. Because looking at the code's funner. But this is really, I think, more meaningful piece of this is if I have some different use cases for creating these external tables. So the first one is aggregation. So let's say I have a file that has all the bank balances for all my customers, and there's withdrawals and deposits in there, and I want to get a daily balance. So I could create a group by query, or I could use windowing functions or whatever I needed to do to summarize these entries. So in this case, it's a very simple example. Sally's got 2 deposits and John has a $50 withdrawal. And so what I can do is I can aggregate those up using a group by and perform the math on them and come up with an aggregated set of data. The benefit of that is this data set's going to be much smaller, and potentially if I'm doing a snapshot fact pattern, I might just load this as the daily or monthly or weekly snapshot, and I generated my new data set. That way I don't have to go with each query and go down to the transaction level detail and perform this aggregation in addition to whatever business logic I'm doing. So this pattern works really good for like inventory levels or banking balances, or even snapshots of things like sales can work too, depending on what you need to do. Another way is if I get a full file, oftentimes what I want to do is work out the deltas, but the source system doesn't support any kind of like change tracking or CDC. In that case, I dump the entire file out to the data lake. So let's say the entire file is a terabyte, but let's say only 10 or 20 records changed. Well, it doesn't make sense to try to load the full terabyte file into either SQL Server or even SQL dedicated pool, and then work the differences out, because it's going to take, I'm going to spend all this time bringing the data in and then just to discard most of it. So what I could do is work the deltas out inside the data lake using the SQL query to basically say, okay, if depending on, I'll look at today's file and I'll look at yesterday's file or what's in the source, and I'll do a comparison on them. It's basically a full outer join, and it basically says if the rows present in both and no values have changed, then that's a no op. If the rows present in both but the non-primary keys have changed, then that's an update. If the rows new in today's file, or it exists in today's file, but it didn't exist in the current data set, then I know that's an insert. And if the record's not in today's file, but is in the source file, then I know that that record was deleted, and so I can remove it. Now, I might not want to physically actually delete it. I might want to do like mark a soft delete or something like that, but that's something that I can control with my business logic. But the idea here is that rather than loading that entire data set, which might be pretty large, I'm going to generate the deltas inside of serverless and load that data. Okay, and then reprojection, just fancy way of saying, hey, I've got JSON data or CSV data coming in. I want to dump it out to Parquet and not really transform much of it. I could do some lightweight stuff, so I could assign data types. I could flatten some of the nested objects. I could remove unneeded columns. Parquet is going to give me the built-in compression. So that's another use case. And then I can also do this with views. So in here, you can see I can create a view on top of a query that's just an open row set query, rather than creating an external table. So the benefit of this is I can just alter the view, since there's no storage behind it, and change this query, and it'll automatically show up in my system. Views are a good practice just in general. They reduce duplicate code, they simplify access, and I can provide security on top of the views to only allow certain people to see the data from the view. And it eases code maintenance. So let's say today we're using this internal storage account. Tomorrow we might move it to a different storage account. So if I change the view, all my queries downstream will automatically point to the new storage account. Stored procedures is kind of the same concept. What's nice about using stored procedures inside of serverless is I can orchestrate multiple things. So I'm not really showing that here, but one thing I might do is I might drop the external table, and then I'll create it, then I'll query it, and maybe do some aggregation or transformation. And I can call that from a single stored procedure. So the stored procedure is going to orchestrate those steps for me. And then I can orchestrate sets of stored procedures with either Azure Data Factory or Synapse pipelines, kind of same thing, similar thing. It also allows me to provide a security boundary, so I can not have somebody have access to these underlying files, but give them the ability to run the stored procedure. So that was orchestration. So this is logical data warehouse. So this was kind of the question. This is what I wanted to show earlier. So the idea here is that we have all of our raw data in storage. I'm going to transform them into kind of more dimensional friendly schemas, and then put Power BI or potentially Azure Analysis Services on top of that. Now with Power BI, there is a data set that it references with Azure Analysis Services as a model. So I could do this transformation inside of Power BI or inside of Azure Analysis Services, but this will give me the MPP engine to do larger transformations at scale, and to do it in Transact SQL as opposed to having to use something like DAX or Power Query or the M language. So it can be a little bit easier to work with. And if I have a BI tool that doesn't fundamentally understand, or that's not using Power BI, that just understands how to connect to a SQL, like an ODBC data source, then I can connect to the storage account. So maybe I'm using, this isn't the case, right? But let's just say, for example, Tableau didn't have a connector to Azure Storage, but it could connect to SQL Database. I could put the Synapse Serverless in front of the Azure Storage, and it could send the queries to the serverless, and I could define my views and do all my transformations in there, and then just point Tableau to it. Now, obviously Tableau supports Azure Storage, but there's other BI tools that you guys might be using that don't. So it's another way to work with that. So for example, reporting services might be one that might have that scenario. And so that's the idea. And so the thing that's missing here is the OLTP source that you're pulling the data. That could be one of two patterns. So the OLTP source could push that data into the storage account on some kind of like timed cadence. So they could have a scheduler or some other third-party ETL utility that dumps the data out to storage. Or I could actually write pipelines to pull that data and dump it out to storage form for it. So I could push it or I could pull it. Okay. So the first thing I do is I create a database. Here I'm going to specify Latin 1 general, bin 2 Utf-8 collation. That will make sure that I don't get warnings. I'm going to create a schema in there called DW. You always want to use UTF-8 collations when using Parquet and CSV to make sure you're supporting the full range of the Latin alphabet. So all the funny characters that European people use. And then, okay, so then we're going to create a login. So in this case, I'm actually creating a Windows login. That's the from external provider. Now I'm doing this in master. I'm giving her sysadmin. I wouldn't have to do that. I could just create her login, but then I can create her as a user inside my Contoso DB data or DW database. So even though it's a serverless environment, I always have my master database. I can create as many databases as I want. I don't get charged for those. So you can almost think of databases kind of like how an Oracle DBA thinks of them, as just containers, right? So there's not anything special about a database other than it's another layer that gives you a security isolation boundary. And then I can create her inside as her user from the login I created in master, and then give her DB data reader, and now she can go run queries against. I can also create custom roles. I can use any of the built-in roles, so DB writer, DB owner. I could also use the underlying security permissions like view table, right, select, all those kind of things to kind of create my own custom role. And so basically the idea is that I have an external data source, and then I have an external file format and an external table that I can create. So let's walk through that. So the first thing I'll do is I'll create a file format. In this case, I'm creating the Parquet file format. I'm going to tell it that it's going to use this compression codec. If my Parquet file isn't compressed, and this is the compression of the Parquet file itself, it's not talking about the internal compression. So Snappy is the one that's supported. Otherwise, I just don't specify this. Here's another example of an external file format where I'm going to create a CSV file. So I'm going to use delimited text. So notice I'm not using CSV. The CSV and the Parquet are things for the open row set. These file formats are used when I'm creating external tables. So I create that file format. I'm saying it's going to be pipe delimited. It's going to use a single quote as a string delimiter. And type default is basically going to say if the value isn't present or if it's null, use the default value as defined for the type. Then I create my external data source. This is very similar to what I did. I can specify my file format as well. And then this is setting up my credentials. So what I'll do is I'll create a master key for the database, and then I'll create a database scope credential. So the master key just enables me to create credentials that I can store securely in SQL Server. I have to have control permissions on the database. And then this is going to basically say create a credential called SQL on demand. And with identity, managed identity, that's going to use the identity of the Azure Synapse workspace. So then what I could do is give that identity of the Synapse workspace permissions to a storage account, or to, it's a little bit out of scope, but I could also assign rights to it in another SQL database, for example. But this will let me authenticate with a storage account where that managed identity for the Synapse workspace has rights to it. So what it looks like is I have my source, my external file format. Those two pieces go together to create an external table. And then from that external table, I can then query it into Synapse. Okay, there's a lot of little objects and stuff you have to create. The idea is that you only create these objects once, and then you build off of them as you reuse them. So now I can create tables. So my table is going to have a data source and a file format. I create an external table. Now notice in this case, I need to actually define, so when I created the other table, I didn't have to define the data set because it was coming from the query source. So there's two types of external tables. In the other example, I was saying select star from a query, and so I was reading that metadata and using that to write it out. In this case, where I'm pointing it to a file location where presumably these files already exist, I need to tell it what columns I want to include. and what their data types are. So it's a little bit different there. Now what's interesting about this is I can create statistics on this table just like I could in SQL Server. Going to be a little bit less, so Parquet is going to automatically have some statistics defined, but this will help me with my query plan. And so if I create the statistic on the country name, then when I have a query that does grouping on this, it's going to generate a better query plan. It'll potentially improve the performance. And then I can put Power BI directly on top of these tables. So, and this is just kind of showing that external tables are different in serverless and dedicated. So in serverless, what's going to happen is when I point it to a folder, it's going to include files with underscore, which dedicated pools, if I create an external table, will ignore those. And it'll also ignore files that start with period. So in this case, like hidden would be included and hidden folder would be included in the serverless, whereas it wouldn't be in dedicated if I say location equals web data. So the idea is web data is where all my files are, and then underneath I have my data.txt. I have a month folder of my data too, and so these folders in serverless will be included. So you have to watch out for that because a lot of big data tools like Spark, for example, will write out an underscore success file that you don't want included. So you need to make sure that you have a process to delete those from that data. So this is kind of walking through what I tried to explain. So on the example down here, I have a CETAS statement, and that's doing select star from CSV, whereas here I'm creating an external table where the main difference is the data in this folder already exists, and so I just want to read it. Whereas in this case, the data in this folder doesn't exist, and I'm going to create it by running the select statement and dumping the data out. Neither of them support inserts, updates, or deletes. They all support selects. Okay, so CETAS is used for outputting data and potentially querying it, whereas external tables are just used for accessing data, and you have to define an existing schema. In this case, the location should already exist. In this case, it shouldn't exist. Okay, so we got statistics. So views, this is a pretty complex example, but you can see how you can actually build this out. So I can do my joins, and the idea here is I wouldn't want to recreate this logic with every query. So I'm creating an enriched view on top of it that basically uses a CTE to summarize or aggregate the data here for taxi rides, and do the same thing with public holidays. And then I'm joining the two in the query and then producing a result set. So you can see how like repeating this code across lots of different queries would be suboptimal, because if I want to go change this and add a new column to it or change a data type, I've got to change it in all my queries. So that's where views can kind of come in handy. The key thing is you want to return only the columns you need. There's no caching, so every time you run a query, you're going to get charged for it, but it'll be a small amount. And just ensure that you're only returning the columns you need, performing group bys, and then ensuring that the compression and the format's optimal for analytics. Okay, so what I'm in my Synapse Analytics workspace here. So how I got to here is I searched for it. So I'm in here, and then I can just say Open Synapse Studio here. If I click this, it'll take me to here. What you'll see is a bunch of scripts I've created in the Develop Hub. So there's all these different hubs here. And you'll notice here that I've got a couple different demos in here. So this is an example that I've kind of already run, but you can see here I create a database, and then inside that database I create my master key, create my different credentials. So this is something we didn't talk a ton about. The managed identity is how I can connect to a using this workspace identity. But if I want my actual NT account, so my let me get that out of the way, jhorner@labs.jhorner.com. Then if I use user identity, it'll actually pass that through to the underlying storage account. So that can be useful in some cases. And then here you can see a couple different things. So these two are anonymous access, and so all I need to do is specify a location. This one is a storage account in another Azure subscription, so I don't own this storage account. But what's been shared with me is this SAS token, the shared access signature. And so as long as I include this with the authentication, this will give me the rights to access the data from here. Okay. And then here's the case where I've got my own storage account, and I'm going to use, or sorry, this one goes with this. So this is going to use this credential to access this storage account. Okay. And so what I can do is if I want to go in here and run a pretty simple query, So I can do an implicit schema. Now, one thing that will trip you up is if you have a dedicated pool, you need to make sure you're actually in the serverless pool, because if I connect to the SQL pool, it won't understand a lot of the syntax and it'll get confused. So I need to make sure I'm in built-in, and then at first I may only have master. So I'm going to connect to my serverless demo, and then I'm going to run this query. And this is it's not a huge file, but you can see here it's going to create those. There's no header, so it just gave it column 1, column 2, column 3. Now, if I contrast that and go in, and notice here I'm giving it the row terminator, so if I were to look at this in storage, it's going to use a new line and a comma. Now, if I go tell it to use this metadata, it's going to go in, and now notice I have column names. I can also look at the messages, and it's going to give me this warning, and this is the collation warning that I was talking about. So what it's saying is, hey, you're trying to load this varchar data in from a UTF-8 encoded field. So you either need to change it to nvarchar or explicitly specify that UTF-8 collation to prevent this warning. So you can see it still works, but potentially if I was dealing with characters that weren't like raw ASCII, so 0 to 127, it would sort them incorrectly and they would render them incorrectly. So that's something to think about. I'm not going to go through this text tab format because that's not as useful. What I did want to show, here's a case where I want to skip columns. And so notice what I did is I just said, I just want the country name, and I put a value of saying what column is it. In this case, it's 2. And so if I query that, I'm just going to do a count on the number of countries and run that. And if I wanted to include other columns, I just need to know what their ordinal position is within that. Okay, escape characters, we can skip through that. That's not super useful. Quote characters. So let's look at querying Parquet just real briefly. So same thing here. I created this data source. It's an open account. Now this is something that I talked about earlier, is if I want to know what the metadata is for this, and I already have the results up, I can run this SP describe first result sets. Notice because I've got single quotes in here and it's a string, I need to double up on my single quotes. But now it'll actually tell me what's the data type for each of these columns, and it'll give me the ordinal position. So it'll still work. So I can still run this without specifying schema, or sorry, in this case I'm specifying date time and an integer value, but I wouldn't have to, right? So I could, if I didn't have that, like right here would be the case where I'm not specifying the schema. So I got those backwards, and it'll come up. This is a pretty big data set, so it's even though we're doing a little bit of filtering and grouping, it might take a while for that to run. You can see here where I'm using some of the filtering. So let's let that run for a second. And then just briefly touching on create store procedures. So this is just what you'd expect, right? Just normal store procedure code. Notice that all these files under the hood are stored in this SQL scripts workspace. They're actually stored as JSON files. And so if I look at, for example, this script, there's all this metadata that gets stored with it. So I can have a name and a description and then the actual SQL query. It's all going to be stored in source control. So I've got them in a source control branch, and I can pull that data out if I want to. Another interesting thing is if I go to the management toolbox, I can go to the built-in pool, and I can control my cost management from here. So here is where I notice I don't have any limits set, but I could enter a daily limit, and notice it tells me how much data I've queried today and this week and this month. So you can see I just started today to start pulling some of these demos together or running them again. So I can put my cost controls on top of it. I also have access to that from configuration values. So I can run these and say, here's my daily limit, here's my weekly, here's my monthly. So those are all supported. And I can set them using the SPs to say, okay, I want a 1 terabyte daily, a 2 terabyte weekly, and I want 3 terabytes monthly. And then if I want to know how much data I've been querying, I can go through and it'll return. So these are the underlying DMVs that are running that query. So let's see if that thing happened to finish yet. So there it ran the aggregate. We can get, if I go to, where did it go? Oh, messages. You can see I've got some interesting metadata that comes back. It gives me a query hash. It tells me how much data I scanned, so 1337 megabytes, but it only moved 1 megabyte, right? And it wrote no data out. So it gives me some interesting metadata, and it also tells me how long it ran for. So this can be useful to determine how much the query is going to cost, and because you wouldn't expect that result set that came through to scan that. Well, you'd expect it to scan that much, but it could be interesting, right? So that might say that I want to take a different approach and not scan so many files or whatever, right? There's some charting stuff. We don't really have time to look into that, but you can do some basic charting from here. I can export that data out to different formats. One last thing I want to show you guys is where I got those data sets from. So if I go in here, they have this knowledge center, and I can browse the gallery, and all these data sets, like there's a COVID data set, there's the European version of it. And if I click on this and go to continue, it's going to give me a little bit of information about it, and then I can add it. Okay. And then it's going to add it as under the sample data sets, and then I can right click here and say new SQL script, top 200 or top 100 rows, and then boom, I'm right in business, and I can run queries against that. So that's helpful. The other interesting thing, just real quick, because I know everybody's got to go, I'm running super late, but I want to show, well, I want to show two things. So one is I can browse my storage accounts as well. So here I can go in and I can see all my folders in my storage account, just like in here. Get in there. Oh, it must be the only folder. The other thing I want to show you guys just real quick is if I did need to, for some reason, I wanted to see this in Storage Explorer. Let me just grab this here. So what I've done is I've got my URL of my storage account, and then you'll notice I've got the SAS token, which I can just generate, or somebody might be able to provide it for me. But basically I take that string and I go into Storage Explorer, and I go in and I say connect. This is a new dialog. This has changed recently. It was a little bit more complex to work with, but I know that I'm going after a storage account, so I can go there. And I can either have an account key or name, or I can use a shared access signature. So in that case, I'll choose that. I'll paste that value in there. So I have to know the name of the account, and I have to have somebody generate a SAS token for me. And then what it'll do, okay, so now it actually lets me browse using that credential. It lets me browse all those structures in there. And so these are all containers within there. And then in here, so this is the books data set. So it's a JSON data set. If there was any data in there, I would be able to see it. Not sure why there, oh, it's probably in here. That's why. So you can see I can go in here and pull these files down. I can download them locally if I want. So it's another way to get into those storage accounts. Now, obviously, if I have my own storage accounts, I can connect to storage accounts with it directly. I don't know why that decided. Oh, there's the file I downloaded. So that's a single line JSON, right? So I've got a lot of options there. I can put security on this. I can browse my storage accounts. So with that, let's open it up for any questions that we might have.
Yeah, cool. We have a question from Ricardo. Can a single query take different times to execute depending on the pool performance or the current state of the pool? And if so, could it render random waiting times for a user running Power BI, even when they run the same query after another, same query again?
Yeah, so it can definitely vary. It usually shouldn't vary much, but there could be a lot of things going on. It could be depending on how long it has to wait to scale up the cluster or scale it down depending on. But generally speaking, if you have statistics and you have everything, the data hasn't changed, it's going to be pretty close, right? So I don't typically observe like huge swings, but you could have some minor differences.
So what would happen if your file format misses a correct Terminator? Are these rows ignored, or will an error be thrown? And also leading on from that, will a similar thing happen if you are using external tables?
Yeah, so basically you'll get a nasty error, or you'll get columns. Just like in SSIS, when I put it over and I'm missing a Terminator, it starts cascading over to the right. You'll get that same kind of thing. If it's really bad where you have an explicit format and you've shifted, like for example, a date into an integer, it'll just bark about it, and you'll get like a, what is that, end of file terminator, or so you'll get that error that says string or binary data might be truncated. So you'll get errors from that if you're using explicit. Yep.
So given the filter predicates can utilize file path, is it important to get your hierarchical directory structure using a sensible naming for performance considerations?
Yeah, so I think it's pretty key, and the big thing is you want to use that structure. You know, if for smaller files, just put in one file and call it good, right? But if you have big data sets like that taxi data set, you can see they put a lot of effort into doing year, month, day, and then individual files underneath the day. And then if you use that year equals format, that's the only way those file path functions will work. So they need to, because it needs to know what column name by the ordinal. And so if you don't have, if I just had 2000 in there, it wouldn't know what value to put back. But if I have year equals 2000, then it says, here's a year field. So I'm going to call it year, and I'm going to provide the value of 2008. So you definitely, structuring these things correctly is critical to performance.
When creating the external files or the external tables, that is, with select star, would we sometime get an equivalent for the SQL command merge, or was that the delta detection we have to manually write?
Yeah, so there's no merge, and so you'd have to manually write it using kind of query constructs in the lake, right?
Your examples have shown creating an external table from a single directory hierarchy. Is it possible to create a derived table from two different hierarchies that would be the equivalent of joining, two different tables, so you can derive one single table?
That's a really good question. So the short answer is no. The workaround is you could create external table 1 that references folder 1, external table 2 that references folder 2, and if they have the same schema, create a view that does a union all from both selects, and there you go, right? But I would push back and say, just put them all under, the key thing is structuring that data lake correctly so that all the files with the same schema are under the same folder hierarchy. But there might be a use case where you'd need to do that. It's that kind of a clever workaround, I think.
The serverless pool, is that identical with the SQL default pool in the normal Synapse Analytics, that you can use Transact SQL or the Synapse SQL only, or can you use the Databricks functionality in the Synapse serverless pool?
So yeah, there are different concepts. So just hopefully you guys can still see my screen. So you've got a serverless pool, and you only have one of them. I can't define others, so it's always going to be named built in, at least right now. And then you have the dedicated SQL pool, which has some overlap in functionality, but it's really the old Azure SQL DW. So we can create external data sources. It can do SQL operations, but the difference is it's bringing its storage internal to that engine, whereas serverless externalizes storage, and it's in a storage account, or one or more storage accounts is where that storage is occurring. Now the Databricks and the Spark thing, that's a whole different kind of concept. I think what they're referring to is when I create a Spark pool, I can mount storage and create Hive tables, and some of those tables can be shared with serverless. Also note here that I'm actually, by default, I get a master database, but I had to actually go in and create all these other databases.
And this leads us on to the final question. So could you define external tables over data set? Sorry, well, we know you can define external tables over data sets, but since they are read-only, can you also use Databricks Delta over this underlying data set to perform CRUD, or would this break the external table?
So I'll put some references together, and I'll send you there's a hack that you can do to reference Delta. The issue is that the hack only supports querying a snapshot of the Delta, and so then what you have to do is refresh it each time the table changes. So the best way to do that would be to create an external table over a storage account and then add files to it after the fact, and then those new tables should show up. But as new folders and files show up underneath that structure, you're going to want to update your statistics and things like that as well. Cool. But just keep in mind, Delta isn't officially supported. There's workarounds to kind of make it work, but it's not officially supported.
Great, but that concludes our questions for tonight. Thanks everybody for joining us, and a big thanks to Json for
Yeah, thank you.
putting up with us.
It's always a pleasure.